Now we're going to look at using the unit vector. If you recall, if I have the vector A, and that is equal to 2i plus 3j, then the unit vector of A, first off I need to find the magnitude of the vector A, which is the square root of 2 squared plus 3 squared, so the squares of each of the components. And the square root of that ends up being the square root of 13. And so the unit vector A, or the unit vector of A, is the vector itself, A, over the magnitude. And so that ends up being 2i plus 3j is the vector A, and I have that over the magnitude of root 13. Now the beauty about a unit vector is unit being 1, the unit vector has a magnitude of 1. So if I now take this unit vector A and I want it to become another unit vector, or another vector I should say, with a different magnitude, I now need to simply times it by that magnitude. So, for example, if I had the vector A is equal to 2i plus 3j, and I wanted a vector in that same direction, but with a magnitude the same as the vector B, which was equal to 3i plus 4j, how would I go about it? Well, first off, I need to find the unit vector of A, which I've done here. Secondly, I now need to find the magnitude of B, which is the square root of 3 squared plus 4 squared, which is 5. So I have the magnitude of B now. I have the unit vector of A, which is a vector which is in the same direction as A, but has magnitude of 1. And now I simply times the two together. So now a vector in the direction of A and with the magnitude of B is equal to the magnitude of B, 5, times the unit vector, times 1 on root 13, 2i plus 3j. And I can actually simplify that a little bit and can use column matrix formation for this to say that that would be 10 on root 13 as my I component and 15 on root 13 as my j component. And there I have it, the vector in the direction of A with the magnitude of B.